This video is going to cover the profile sheets in accordance with the plans reading class. So again, profile sheet, we're looking at it from the side view. We're looking at it like that. For profile sheets, you can see the EPG handout on plans and profiles. Profiles can either be shown on the bottom half of the plan sheet or have an entire sheet dedicated to the profile. It shows the vertical alignment, the hills and sags standing on the shoulder looking toward the center line of the roadway, typically controlled by the K value from a speed table, and we'll talk more about that. So here's a full plan sheet. This one has just one profile in the whole plan sheet. You see there's a vertical curve length of 400 and a K value of 49. And K is how many feet you go before you raise it or drop it 1 degree in your slope. Okay, so that's what that's all about. How much do you need? And a lot of times these profile sheets are exaggerated. They're shown to be exaggerated so that you can see the sags and the hills that's going on with them. Okay. Now, sometimes you can fit two profile sheets on one, and that's what a lot of people like to do. Our bridge profiles, they do a lot. They end up with a whole bunch of that. So in this case, you can see there's two profile sheets in this one. You've got one cutting across this top here, and then you'll see on these profile sheets you have an elevation on the left side and you have the stationing on the bottom. Same with this one. You'll see the stationing across the bottom, you'll see the elevation. Usually you'll see your curve data, your information on it, which is right in here. This one, not much of a hill or sag going on here, but you can see that's the profile of it. That's looking at it from the side. Types of profiles that we use are roadway and median center line. They're the same. And then you have existing grade. You want to see the ground. See that previous slide out there. Didn't have any. You can see existing ground right here. And you can see it up here. You got some existing ground going on here. You got some existing ground here. So it's always dashed is what you'll see on that. Edge of pavement line, you'll see that. We do profiles on edge of pavement lines. We do a profile on a shoulder line. And ditch profiles are used a lot. Other items that may be shown on a profile is the storm sewer system or underground utilities. You might see those on your profiles sheets. Now, to scale, the way this works is it's 100 foot between horizontal measurements and 10 foot between the vertical measurements. It's skewed to show the changes in elevation. So yeah, we change it so that you can see that change, that the big curves instead of just a small little curve that you can't see. That's why the elevation's like it is. So the numbers across the bottom match with the stationing along the element or alignment, like I was saying earlier. So you got 617, 618, 619. That's the stationing. Again, they're measured in 100 increments, 100 foot increments. The verticals, though, they're measured in 10 foot increments to skew that view so that you can see a more drastic curve. In this case, each green line is 10 foot, and then each purple line, or whatever color that is 2 foot. Okay. What is a grade? When working with the roadway profiles, the term grade and gradient are typically used to describe the change in elevation for the line work displayed. Grade designations are usually shown as a percentage, but can also be shown as an expression of feet per foot. For example, a grade has been calculated at plus 0.0425 feet per foot. This can be designated as plus 4.25% or as a 0.0425 foot per foot. Now, normally, a lot of times we use the 4.25% in this case. Okay, more about the grade. What's a positive grade? Well, a positive grade is a line that rises as station increases. So we go from 625 to 650, and you see we're going up. Okay, we're going up. Going from 2550 to 30 on your stationing, and your elevation is going from 625 up to 650. So that's a positive gradient. A negative gradient means it's decreasing. So we're starting over here at this 30 plus 00, and we go to 34 plus 25 on our stationing, and our elevation goes from 650 down to 642.50. That is a negative gradient. Zero gradient is a line that neither rises nor falls as stations increase. Vertical curves, just like the horizontal curve, there's a lot of information on what a vertical curve is. The important ones are the beginning of the vertical curve, a point where the tangent ends and the vertical curve begins, and then the EVC, which is our end of vertical curve, that point where the vertical curve ends and the forward tangent begins. Those are important. The length of the vertical curves important. We use that a lot in design. Just some important stuff. Cut and fill. Cut is an area of existing ground that falls above the proposed project profile. Fill is an area of existing ground that falls below the proposed project profile. Designers attempt to balance cut and fill for a job, and profile sheets can help them do this. However, the profile line only indicates what the ground is doing at that one location along the project's length. So profile information needs to be used with cross sections to gain a more accurate picture of the cut and fill for the project, and we'll talk about cross sections later. And that concludes the profile video.